For bell work today, you did a whole bunch of multiplication problems where it was just the same thing times itself over and over and over again. And it was a little bit exhausting, but it set you up for something cool and a really cool realization that I'm hoping to coach you through right now. If you were given a problem that says, assume something is a perfect square, and then it asks you to figure out what this missing trailing constant is, that's something we can absolutely do. See, based on the practice that you've just done, you might already have this in your head, but you'll recognize that this 8x, or x squared plus 8x plus something, you know that this is the product of x plus 4 times x plus 4. Because you know that x times x is x squared, x times 4 is 4x, this middle x times 4 is another 4x, and in the last term, 4 times 4 is 16, and this 4x plus this 4x adds up to 8x. So in this really cool way, even though you didn't know what the last term c was, knowing that this middle term was 8x was enough for you to realize that the factors, if it's a perfect square, would have to be x plus 4. And so we would rewrite this just as x plus 4 squared. And so now that we have our multiplied out version of this, x squared plus 8x plus 16, it's really easy to see that this missing term c would have been that 16 right there. So this is the cool logic behind it. The formula that teachers often teach is basically this. If you have some format of x squared plus bx plus c, then this middle term, b, it could be factored into x plus 1/2 of b over 2. Half of 8 was 4. And then c would be equal to b over 2, like whatever that was. In this case, b over 2 was 4 squared. And 4 times 4 is 16. So that's the formula. Try not to use it. It's more fun without it.